Hello, everyone, and welcome to your lesson of physics. So, we continue our past paper practice of Newtonian mechanics, and the topic that we have for today is turning effect of force, aka moment of force. And pretty much all the questions that we'll be solving today are kind of most recent questions, like the very first one I have from 2021 October November session P22. So, for the most part, we'll be solving the recent questions. Let's start with the first one. And before we start it, primarily you need to be aware of these two mathematical expression for finding the moment of force. First of all, moment of force, if you want to denote it by m, that equals to force times perpendicular distance between the force and the axis of rotation. And we then extend this formula, and we say product of force and perpendicular distance is constant if the system is in equilibrium, right? So primarily we'll be using these two formulas for the most part, right? But if the question is mixed with another topic, like which it generally is, it is very often mixed with mass weight density and forces as well, then you have to use some additional formulas as well. But for this topic, I mean, if we talk about this topic, then only these two formulas would be used explicitly. So here's the first question. Turning effect of a force is made by its moment. Okay, they have given some information. Let's move to the question itself. Write down an expression for the moment F about the axis at X. Right, the expression, like I said, the expression or the formula or this thing is moment equals force into perpendicular distance or displacement. That is the expression. Now on figure 8.1 to show what is meant by the other term, any other term in your expression. So basically you have to define what do you exactly mean by the distance d in that case. So it should be clear that whenever we use the distance in moment of force, then that distance refers to the perpendicular distance between the line of force. This is your line of force, and this is your axis of rotation. So the perpendicular distance between these 2 points, that would be your d, right? Perpendicular distance. How do we know that is perpendicular? It would make an angle of 90 degree, right? Matter of fact, you have to draw the distance, label the distance d in such a way that it makes 90-degree angle with both the lines, with the line of force and the line of or the axis of rotation, right? State the principle of moment, right? A theoretical one, again, should be aware of it. We can't afford to lose marks in question like that. So for an object in equilibrium, for an object in equilibrium, the sum of clockwise moment equals the sum of counterclockwise moment. Sum of clockwise moment is equal to the sum of counterclock or anti-clockwise movement. All right, so this was a part B, part 1. Now the next one is describe an experiment to verify the principle of moment. Include a diagram to help the description. So whatever you have written previously, you have to come up with an experiment that would prove that. So a very common experiment, and generally this experiment is always conducted in the lab. So take a meter rule, all right, and you balance the meter rule on a pivot. Sometimes they use a triangular prism as a pivot. Anything which is convenient can be used. So we have a meter rule, and then we take, at least we should be having two loads, and by load generally we have uh, sometimes we have a coin. We put a thread around the ruler and then we attach the coin with it. That serves as a load. It exerts a force on that point. Or simply, if you have certain mass, known mass, you can place it on one side of the meter rule. Then you take another mass which is different from this mass. Let's say it is slightly heavier. Place it on the other side of the meter rule. And then you try to balance them. After you have balanced the meter rule, now you place the masses on both sides, you place the loads on both sides, and then you try to make sure that you adjust these two masses in a way that the system or the meter rule is balanced. Okay, so first of all, you can place this one at any random point, but the second one, this one, you place it in such a way that the meter rule is balanced, right? So this one, this would be the, should make the general sense of it. And now let's make it precise. Let's add some key terms and keywords. So this one was your meter rule, this is your pivot. All right, you can call this one load 1 or f1. This would be your f2, and the distance that you take for the force 1 from the pivot, call it d1. Right, this was your pivot, and the distance that you take for the force 2 from the pivot, you can call it d2. All right, so now you can write down the pointers here. Okay, all right, so these are the general steps that you need to write. All right, that's the generic statement that you can write as the answer for this one. First, you balance the meter rule, you balance your scale, then you add the masses, then you balance it once again, measure the distance, and obviously you should know the mass. From mass you can calculate the force, you can calculate the weight, and then you equate the two moments, counterclockwise and clockwise moments, and if those moments are equal, then that would imply that your meter rule was not drifting to any side, the meter rule was balanced. Right, so every time you get a question like this which you have to verify the principle of moment, you can write these steps, right? And the diagram, this diagram would be okay. You write down these steps, draw the diagram. All right, let's move on to the next one, which is calculation based. Okay, a worker carries a ladder on his shoulder. His shoulder acts as a pivot. Okay, so this point is the pivot. You can write P here. All right, so first of all, the gravitational field strength is 10 Newton per kilogram. Calculate weight of the ladder. So mass of the ladder is already given, 8 kilograms. You need to find the weight of the ladder, right? Has to be very easy one. We simply apply the formula W equals mg. Weight equals mass times gravitational field strength. So 8.0 times 10. If the gravitational field strength is not given, you have to consider it as 9.8 according to the updated syllabus. So it would be 80 Newton. Okay, Newton is the unit of weight because weight is a force, and the unit of force, any kind of force, is Newton. All right, the next one that we have is center of mass. State what is meant by center of mass. It's quite popular question, right? There is a straightforward answer to that. Point where whole mass or the entire mass of the object appears to be concentrated. All right, and generally the center of mass of a uniform object is at this at uh, physically the center of it. So if that is a uniform meter rule, then the center of mass would be at the midpoint, right? Right at the middle, provided that the object is uniform. Uniform means the mass is distributed evenly across the length and across the width. The center of mass of the ladder is not halfway along its length. So just the same thing that I was saying. State what this shows about the ladder. So simply it tells that the mass on the ladder is not uniformly distributed, and we can see from the diagram as well. You see, uh, if I split the ladder into half, and you see from on the left side there would appears to be more mass because the ladder appears to be wider from that side, but on the right side there appears to be less mass. So the center of mass cannot be at the middle. So what do we know from here? We know that mass is not distributed evenly. Evenly distributed on the ladder. Alright, the next part. The center of mass of the ladder is a horizontal distance of 0.90 meters from the worker's shoulder. Calculate the moment about the worker's shoulder of the weight of the ladder. Okay. So the person's shoulder, that is your pivot, which was stated previously as well, And we can also see in the diagram that the distance between the point where the weight of the ladder would exert and the pivot, which is the shoulder of the person, is 0.90. This is the distance between, we can also say this is the distance between the line of action of force and the axis of rotation, right? Because that is the point which they have called as center of mass. So the weight of the ladder would be exerted vertically downward at that point. And the point P is your pivot, and the distance between pivot and the perpendicular distance between the pivot and the line of force is 0.90. And we need to find moment, right? So should be straightforward. Moment equals force into perpendicular distance. So the force, the weight of the ladder was 80, which we calculated in the previous part, times 0.90. Then you hit it on the calculator. Should be something slightly less than 80. Yeah, so we get 72. So we write 72 with the unit of Newton meter. All right, write Newton meter because force was given in Newton and the distance, especially the distance, was given in meters. Had the distance been given in centimeters, the answer would have been the unit of the unit would have been Newton centimeter. If you uh, don't want to convert centimeter into meters. All right, let's move on to the part 5. Yeah, and that's the last part of this question. Your 15-mark question this one was, and the last part is of 3 marks. Okay. All right, so let's continue with the next part, part 5. A bucket of weight 87 Newton is suspended from the ladder at a horizontal distance of 1.3 meters from the worker's shoulder. Okay, so yeah, the weight of the bucket. Okay, we can directly see that we have a bucket over here. The weight of the bucket is 87 Newton, and from the pivot, which is the shoulder of the person, from the pivot, the distance of that force is 1.3. Okay, this is the information that we have from the first two sentences. The worker helps the ladder. The worker keeps the ladder horizontal by exerting a vertical force at the point L. All right, L is a horizontal distance of 0.54 meters from his shoulder. So you go back over here, this is a point L. So the person is exerting a force of, we don't know about that. They have called this force as L. He is exerting the force, a vertical force at the point L, and the distance between that force and the pivot is 0.54. We can see from the figure as well. Calculate the size and direction of the force exerted at L. Okay, you need to find the direction of force and the magnitude of force. All right, so sometimes it appears to be tricky when all of these stuff and everything, the actual diagram is given. So it would be, I always recommend that you can draw another diagram for the sake of convenience. So this is your meter rule, right? So you have your meter rule here, and the point P is the pivot. Okay, the shoulder of the person is uh, serving as a pivot. You can call this one pivot. Just draw this thing for reference so you know that this point is a pivot. So on the left side we have a force which is downward, which is being exerted downward like this, and the amount of that force is 87 Newton. You could call it F1. So F1 is 87 Newton, and the distance between that force and the pivot is also given in the diagram. It is 1.3. The distance between F1 and the force F1 and the pivot is 1.3, and you could call it D1 as the distance of the first force from the pivot. Alright, what's the other force? The weight of the ladder, and it's on the right side of the pivot. So here's the weight of the ladder, and from the right side it also acts downward, and the weight of the ladder was calculated, we calculated that it was 80 Newton. Okay, you can call it F2. That is your second force. And what is the distance of this force from the pivot? Well, the distance of this force from the pivot was 0.90, right? We can see from here, distance of that force from the pivot, you can call it D2, equals 0.9 meters. All right, so we're done with this thing. I'm going to raise it off. And now what we are left with is the force L. They say it is a vertical force. They haven't like actually mentioned the direction of it, but from the figure we can assume that this force would be upward like this, and it is at a distance of 0.54. Let's call this force L, and this force, the black force, is at a distance of 0.54 meters from the pivot. All right, the thing with the direction of the force, we have just assumed, all right, just by looking at the picture, that this force has to be upward, right? Yeah, so the thing about the direction of forces, we have just assumed that it is upward, just seeing from the picture. So you just calculate the force that way, the magnitude of force with whatever direction you have assumed, then you check your answer. If your answer is with the positive sign, then it means that whatever direction you assumed is the correct direction of force. And if the answer you get is negative, the value of force that you get is negative, let's say negative 10, then it would imply that the actual direction of force has to be opposite to the direction of force that you initially assumed, right? So right now I'm just assuming that the direction of force is upward, and if my answer is positive, that means that direction is okay, the force would be upward. But if um, the answer is with the negative sign, then it would imply that the force would be downward. So uh, if I try to look at the direction without solving it, so it shows the worker keeps the ladder horizontal by exerting a vertical force at the point L. They simply say it's vertical force, so we're not clear with it that if it's going to be upward or downward. All right, so we don't know nothing about it. So just taking a look at the picture, it can be downward because on the left side there's a bucket. In order to counter the bucket, you should be pulling the ladder downward from that point. All right, so now let's apply the principle of moment in order to find the force L. Okay, we need to find the force L, so let's apply the principle of moment. So yeah, I'll be applying over here. Let's enlarge this one. All right, so when you're applying the principle of moment, the only thing that you need to consider is on one side of the equation you have the clockwise moment, the sum of all the clockwise moments, and on the other side of the equation you have sum of all the counterclockwise moments. All right, let's start with the force F1. So F1 would produce counterclockwise moment. Okay, so we can write F1 into D1. What is the other force that would produce anti-clockwise moment apart from F1? We're done with F1. You see, if you follow the direction of force F2, it would be tilting the middle rule in this direction clockwise. But for the force L, it is upward from the right side, so it would also produce anti-clockwise moment. So we add it on the left side into L into the distance of that force from the pivot. Let's call it D3. All right, we can call this distance as D3. All right, I've written with that distance D3, and the force F2 is the only one that produces clockwise moment, so we write it on the other side of the equation, and the distance of that force F2 from the pivot is D2. All right, so let us now insert the values in it. Yeah, so I've written F2 times D2. So let us insert the values. F1 is given as 87, D1 is given as 1.3, plus force L is something that we need to calculate, so let's write it down as it is, and times D3. Uh, yeah, the distance of that force L from the pivot was 0.54. We write it over here, equals to F2. F2 was 80 times the distance of that force from the pivot is 0.9. All right, so this is something that you have from here. Let's bring it down there, and I'll just hit it on the calculator. All right, so we have to solve for the value of L, and like I said, depending on the sign of the value of force, we can tell if the direction of force would be upward or downward. If the matter of fact, if the value of L is with the positive sign, that it means the direction that we assumed upward is actually upward. If the value of L is with the negative sign, then we say the force is downward. So let's hit it on the calculator. $87 times 1.3, 87 times 1.3 We get 113.1 from here plus 0.54. L would be written as it is because that is something that we need to calculate, equals. Then we have 80 times 0.9, which was 72. All right. Yeah. So the force would actually be downward because the answer would be with the negative sign. So 0.54 L equals 72 minus 113.1. And then we can say L equals 72 minus 113.1. It is negative 41.1 divided by 0.54. We get 0.54. We get 76. Two significant figures, we get 76 with the negative sign, that many newtons. So the size of the force is obviously nothing different with the size of force. The size of force would still be 76 newton, and the direction of force would now be downward because we assumed that the direction of force would be upward. We applied the principle of moment that way, considering the force is upward, but now our answer is with the negative sign. So that means the direction of force that we initially assumed is the actual direction is opposite to the one that we initially assumed. Initially we assumed it upward, answer it with the negative sign. That means the actual force is downward. So that was the question number 1. Let's move on to the next one. All right, everyone, on to the next question. Question number 2. Explain what is meant by a moment of force. So primarily, whenever you get a question like this, especially moment of force, you better define it mathematically. So I'll be saying moment of force product of force and the perpendicular distance from pivot to the point of, or to the line of the application of force, or the line of action of force. All right, so the next part, by taking moments at about A, calculate T. So you need to find the force T, and whenever you get a situation like this, it is obvious that you need to apply principle of moment. And how do we know that we can apply the principle of moment? Because principle of moment can only be applied if the system is in equilibrium, and they have stated that yes, the system is in equilibrium. So that means we can safely apply the principle of moment. So let's call this one as F1. All right, call this one as F1, and the perpendicular distance between that force and the pivot, right, this one, pivot, the perpendicular distance between this force and the pivot is 8. You can call it D1. All right, let's write D1 with it. D1 equals to 8, and 2000 newton that produces clockwise moment, you can call it F2, and the perpendicular distance between that force and the pivot is given as 2.0 meters. You can call it D2. Then you can simply apply the principle of moment. F1 into D1 equals F2 into D2. All right, now what is F1? F1 is something that we need to calculate, and they have labeled it as T. We write just T here times 8 equals 2000 times 2. and that would be 4,000 divided by 8. All right, so T would be 4,000 divided by 8. 8 fives of 40, and 2 zeros follow as it is. So the force T has to be 500 Newton. All right, let's move on to the next one. It says the force T and the force that the rope exerts on the man. First of all, what is the force T? The force T is the force that uh, the person is exerting on the rope, because force T represents the force that is used by the person to pull the rope toward itself. So T is the force that the person is exerting on the rope. What we need to find, yeah, and the force that the rope exerts on the person are related by Newton's third law. State the relation between these forces. The two forces, according to the Newton's third law, are equal in magnitude, and opposite in direction. Two forces are equal in magnitude and opposite in direction. All right, then we have the next question. The girl weighs 550 Newton, is sitting on a seesaw with her brother. Figure 2.1 shows her brother with weight W, which is unknown, sitting 1.1 meter to the right of the balance point. Okay, calculate W. All right, so the seesaw is balanced. Okay, so which implies that we can use the principle of moment, right? So straight away, when you given with two forces, doesn't matter if both the forces are given, might be one force you need to calculate, but they talk about two forces and they talk about two distances from the pivot. You have to apply the principle of moment. So the formula would be, once again, F1 times d1 equals to F2 times d2. You can call this one F1, that would be your d1, this would be your d2, and that would be your F2. Let us write down the data. F1 times d1 equals F2 times d2. All right, F1 is 550 times 0.86 equals F2, which is unknown. They label it as W, so just write W there, times d2. d2 is the distance between the force W and the pivot, which is 1.1, right, like a labeled on the diagram. Then we simply need to hit it on the calculator, and W would be 550 times 0.86 divided by 1.1 would be 430 Newton. All right, so weight of her brother is 430 Newton, which means his mass would be uh, something around 43 kilograms, right? Something around, because right now we're not, according to the new syllabus, we can't use the gravitational field strength as exactly 10, we have to use it as 9.8. In A levels we use 9.81, but previously in O levels we used to uh, consider it as 10 Newton per kilogram. Anyway, the next part is the girl and her brother slide equal distances along the seesaw away from each other. Describe and explain what happened. So they moved at the equal distance away from each other, and obviously if they move equal distance away from each other, the system would be unbalanced because their weights are not equal, so the system would be unbalanced. So if girl moves the same distance and girl and boy move the same distance, the seesaw would be tilted more towards the girl's side because our weight is already greater than the weight of our brother. So now we can just summarize it. When they slide equal distance, equal distances, due to more weight of the girl, the anti-clockwise moment, right? Because from this side, the girl would produce counterclockwise or anti-clockwise moment. So the anti-clockwise moment, clockwise moment becomes greater than the clockwise moment, and the seesaw tilts towards that side. Tilts towards the girl's side. All right, since they are having different weights and the weight of the girl is more compared to the weight of her brother, so the girl has to move backward small distance and the boy has to move backward by a large distance, and that way the seesaw can remain balanced. All right, moving on to the next one. So here's a situation that is given. uh, let's get straight to the topic that we need to calculate mass of the cube. All right, mass of the cube is something that needs to be calculated. Where is the cube anyway? Okay, over here. So how many objects are there on this seesaw or on the uh, wooden plank? Only two. So you can call this one as M1 and you can label this one as M2. And matter of fact, you need to find the value of M2. That's it. Find the value of M2. Mass of the cube needs to be calculated. All right, and pretty much everything is given. So M1 is given as 0.050 kilograms, and the distance between that mass and the axis of rotation or the pivot is given as, it starts from 10 ends at 50, so that means the distance between these two would be 40 centimeters. Okay, so I could say d1 equals to 40 centimeter, and similarly the distance of the cube from the pivot, it starts from 50 and it ends at 75. So how much distance do we cover in between? We cover 25. So d2 you can say is 25 centimeters, right? Why are we taking these distances? Because every time you apply the principle of moment, or a matter of fact, every time you calculate moment, the distance has to be from the pivot. Distance from that object, from the center of the object till the pivot. That is the distance that we consider in that case. So let us write down the principle of moment. F1 times d1 equals F2 times d2 when you have only two forces, and both produce, one produce clockwise, the other one produce counterclockwise moment. Now the same formula can be considered as, or can be written as, if they talk about masses, because in this question uh, they don't mention the force, they have mentioned the masses straight away. So you can like write the formula in terms of masses. That would mean the same thing, right? It doesn't make any difference if you write in terms of masses as well. Why did it not make any difference? Because if you talk about the force, then we say that force in that case equals to the weight of the object, and weight of the object can be calculated as mass times gravitational field strength, like this. And then you can say F1 could be written as m1g into d1, and F2 would be written as m2g times d2. Why are we not writing 1 and 2 in the subscript with g? Because that represents gravitational field strength, and gravitational field strength is same for both the masses, because both the masses are placed uh, at the same place. Okay, they are at the same place. The value of g would be changed if you dramatically increase the elevation, or there's a dramatic difference between the positions of the two masses, like one mass you have placed on the ground here, and the other one mass is placed somewhere on the Mount Everest or on a mountain, but that doesn't happen practically. Okay, then you have to produce a system that would produce moment, which is practically not possible. So g can be cancelled out on both sides, and the formula that you'll be left with is m1 times d1 equals to m2 times d2. So instead of writing in terms of forces, you can simply write in terms of masses, and then you can highlight m2 because we need to calculate m2. Now m1, the mass of the first one, 0.050. 0.050 times d1 was 40, and we're not converting centimeters into meters because both the distances are given in centimeters, so that wouldn't make any difference. M2, we need to write it down as it is because that is something that needs to be calculated. So let's write it down as it is, times d2, 25. Now let's directly hit it on the calculator. 0.050 times 40 divided by 25, we get 0.08 kilograms. All right, because the other one mass was given in kilograms, and say in the answer we don't have to use the distance, so the units of distance were automatically cancelled out, so you don't need to actually convert into meters. But even if you do so, that won't make any difference. All right. So the mass on the, you see, this mass was 0.050 and this one mass is 0.08, or you can write 0.080 kilograms. Okay, in three significant figures, sorry, in two significant figures, you can write it as 0.080, just to make it consistent with the first mass. Now, if you observe, or if you take a look at the question, the mass m1 is less as compared to the mass m2, and the system is balanced. And the only way that you can balance two different masses is in such a way that the heavier mass sits close to the pivot. So the heavier mass sits close to the pivot. That's why the second mass is having a distance of 25 centimeters from the pivot. And the lighter mass sits away from the pivot. And that's why the lighter mass, M1, sits at a distance of 40 centimeters from the pivot. Only then they can balance their moment. The cube has a volume that much, calculate the density. Okay, density equals mass over volume. We already calculated the mass of the cube, which was 0.08 divided by 1.6 into 10 to the power negative 4. You can write it as straight away on the calculator. Make sure you insert the fraction, otherwise there's every chance you commit a mistake, because the calculator follows the Dimas rule. So density turns out to be 500 with the unit of kilograms per cubic meters. Alright everyone, so that's it for today. We'll be seeing each other in the next video lesson. Take good care. Allah Hafiz.